the 15 second part is like failure classification. Can you see the slides? Hello?
Sir.
Yes, sir.
Can you see the slides?
Yes, sir.
Yes, sir.
Yeah, you can see the topics that are there remaining in the fifth unit. Failure classification, storage structure, recovery and atomicity, log-based recovery, shadow paging, recovery with concurrent transactions, buffer management, failure with some topics we will cover from this. I think remaining also you can understand. If you don't understand, if possibility is there, I will take some classes. Otherwise, you can read it yourself. But today I can assure you that I will cover at least half of these topics, from failure classification to shadow paging. But only thing I expect from you is your interest. I don't know. If you are not interested, then I'm not going to continue. Hello? Am I audible?
Yes, sir.
So what about the remaining people, Ajay? You're not interested?
I don't know, sir, but I shared in the group to join.
Okay. Okay, right. So you are interested from your side, there is no problem. Are you sure? Hello?
No problem.
Yes.
Yeah, I'm asking repeatedly because because after the hours I'm taking, even for me also, I'm putting some extra effort of preparing and explaining. That's why I'm asking this question. I think that I'm not burdening you with extra classes. So my only motto is like you can prepare well for the external exams. Okay. So failure classification, if you see, so as you know, the transactions, while the transactions are going on, there are different types of errors or failures may occur. Like, logical errors, okay, and system errors, system crash may happen, disk failure may happen, okay. So these are the different ways that a transaction can fail. So logical error means simply a transaction cannot complete because of some internal error condition, okay. Transaction may or may not complete. So I have given you a simple example of transaction like debit and credit. You are transferring amount to some other person, A transferring amount to B. From A it is debited, from B it is not credited. It's an example of transaction, and it's an example of incomplete transaction as well. So it may occur due to internal error condition, the logical errors, okay, and system errors also. System errors, the database system should terminate an active transaction. Okay, for example, a deadlock may occur while the transaction is going on. Okay, deadlock means there are multiple number of processes are going on, like all are going in a state where there is no progress in the system. I already told you what is a deadlock. Generally, deadlock is a term that is used in the operating system context. Okay, in the database system must terminate an active transaction due to an error condition. Okay, so errors may occur due to some deadlocks as well. Okay, not only because of logical errors, but also because of system errors. Okay, and next, system crash, simply because of hardware failure. What is a hardware failure? So suddenly a power cable might not be plugged in, or a power cable may have some loose connection. So you may have some hardware issue or software issue, a power failure, okay, that will cause the system to crash. Okay, and we should have that whatever the contents are there in the database, non-volatile storage contents should not be getting corrupted. Just like your system failure, just imagine that suddenly your system is not working. Power failure happens. Still that whatever the storage you have within the system is safe. Similarly, whenever a system crash occurs, the database also should not get corrupted, and it should have the storage contents, non-volatile storage contents. And disk failure is like head crash or similar failure destroys all or part of the disk storage. Sometimes the disk may fail, maybe the storage device may fail because due to some problem, either the some part of the disk can be failed, okay, or head may crash, disk head may crash. So because of these reasons, transaction can fail. Are you getting what I'm saying? All of you just keep your mics, like enable your mics. Is there any disturbance? Hello? Pratyusha, Pratyusha.
Sir, actually, she is in journey.
She's in journey now. Why?
Good evening, sir.
Good evening. Where are you?
Sir, actually, I'm traveling, but I'm listening to class.
Okay, okay. Right. So,
Okay, sir.
So you got the concept. The transaction may fail due to logical errors, or due to system errors, or due to system crash may occur. Disk fail may happen. So because of all these reasons, a transaction may fail. So we have just classified these failures. What are the different reasons transaction can fail? Possibly due to logical errors, or due to system errors, or system crash, or disk failure. So this is simple information about failure classification. Okay. And next, volatile storage, storage structure. Like very well, what is a volatile storage and what is a non-volatile storage? What is mean by volatile and what is mean by non-volatile? Hello. What is mean by volatile and what is mean by non-volatile? Pratisha. Hello.
So,
It changes is volatile.
Okay. Changes.
It keeps on changing, sir.
Yeah. So volatile storage is something that is temporary. Simply to say simply, volatile means temporary storage. If the power is off, we are not able to have the data. Okay. It means that it does not survive the system crash, or it if the power failure occurs. Okay. So you don't have any data in the volatile storage. Example, main memory storage or cache memory will come under the volatile storage. So this does not survive the system crashes. So coming to non-volatile storage. So non-volatile means even the power is off. If you just again you turn on the system, you have the data. Non-volatile means it's a permanent storage. Okay, non-volatile storage means it's a permanent storage. So this will survive the system crashes. The example is like a disk or tape. Okay. And there is other form of storage like a stable storage. We refer to as stable storage. This will survive all types of failures. Okay. One is a volatile storage. Other is a non-volatile storage. Other is a stable storage. So this is possible only by maintaining multiple copies on distinct or non-volatile media. So we are maintaining multiple copies. we are maintaining multiple storage devices. Okay, multiple. I mean, you can say the same data is stored in multiple non-volatile devices. Okay, so our multiple copies are stored on distinct non-volatile media, whatever you say. So here, for example, instead of, for a simple example is general example that is similar, like you are just taking the backup of your hard disk data into some external hard disk. That means you are having multiple copies of data. The same data which is in the system is also present in external hard disk device. That means you are having multiple copies of data. Even though due to some reason your hard disk may fail, but you still have other copy in your external hard disk. So similarly, when we are maintaining the storage in the database also, we are going to have a like multiple copies on distinct non-volatile media. This is simple. This is very simple to understand, and this is very basic things also. You already might know about these terms: what volatile storage, non-volatile storage, what is a volatile storage, like main memory, cache memory come under the volatile storage, and disk and tape. Okay, hard disk. Generally, hard disk is referred to as non-volatile storage. Stable storage is nothing but multiple copies on distinct non-volatile media.